Welcome to our webinar on predicting customer churn in telecom with machine learning, where we demonstrate how you can use our new customer churn solution template to start predicting customers who are at the risk of churning in the telecom industry, so that you can start implementing the right retention strategy before it's too late. First of all, I'd like to thank everyone for taking the time out of your busy schedule to join us today. We promise you it's going to be worth your while. Let me first introduce our company to you. PI Exchange is a deep tech company that focuses on the mission of democratizing data science, and AI to everyone. So if you're not a data scientist or machine learning expert, don't worry at all. Our flagship product, the AI Analytics Engine, is a no-code machine learning tool that makes it easy to develop machine learning applications to solve just about anything. For today's session, I'm joined by our head of data science, Ramanan, and he will take you through step-by-step on how to use our customer churn solution template. We will start the webinar with some introduction, followed by the customer churn prediction use case walkthrough, and we will also have a Q&A session at the end. So if you have any question for us at any point of the webinar, feel free to pop your questions in the Q&A box and we will answer them for you at the end. Now, if you're a company that does not have a big data science team and you're wondering how to lower the barrier of entry into machine learning, these are the typical requirements that would need to be fulfilled. So you would first need a complete end-to-end machine learning tool that can take you from data preparation and analysis of raw data all the way to generating prediction in the most efficient and time-effective way possible. It should also streamline the traditional end-to-end machine learning process so that even if you are non-technical, regardless of which industry you come from, you can create and deploy your own machine learning pipelines. For today's walkthrough, we will be using such a tool. We will be using our flagship product, the AI Analytics Engine, so that the focus is on the domain expertise and use case and not the technical concepts or software tools. Now, let me briefly talk about customer churn prediction. Customer churn prediction use cases fall under two broad categories, depending on the business type. Firstly, we have transactional businesses that will want to predict whether an active customer's transactional activity will decline in volume or frequency. On the other hand, subscription-based businesses will want to predict the likelihood of each customer terminating their ongoing paid subscription service. For this webinar, we will be showing how machine learning can be used to predict churn in a subscription-based business. Some examples are telecom, internet service providers, and online video streaming. All right, before we jump in, we would like to get to know all of you better. So we'll take the next 2 minutes to ask you a couple of questions so we really appreciate it if you could participate by answering the poll questions. All right, we have the first question, which is, which industry are you guys from? Awesome. I see some answers coming in from Telecom, a few others as well. Please drop your answer below. We'll really be interested to know. Okay, just to make sure we are all at the same page. A customer is considered to have churned when a company loses the customer during a certain time frame. This could happen for various reasons, varying on a case-to-case basis. As we all know, customer churn is probably the single most important metric to get right when it comes to any business. It indicates if your customers are getting value from your product or service and is the key driver of revenue. It is an important concern for any business, big or small, as it directly impacts revenue and business growth. So customer churn introduces not only loss in income, but also other negative effects on the operations of the company. In many industries such as telecom and banking, customer churn prediction plays an important role in business success due to the fact that attracting new customers is 5 to 10 times more expensive than retaining existing ones. So from an efficiency standpoint, it's definitely worth it to make sure your customers stay. Moving to the second question, how high do you think the average churn rate in global markets can be? Okay, I'll reveal the answer now because so far none of you have gotten it right yet. The answer to this question is actually 30%. And just for your reference, the average churn rate that is considered good is between 5 to 7%, although of course it varies across different industries. Now, if you're wondering, what can I do about customer churn? Let me tell you that customer churn is bound to happen, but it pays to do everything in your power to reduce it as much as possible. That's because it's not just a business problem, that's just a side effect. It's about understanding why a customer along the way somewhere isn't happy. That's definitely a problem worth solving. And if you can get it right, it's not just the immediate revenue you stand to gain, it's the multiplier of delivering a better customer experience. That being said, customer churn prediction and prevention is and should be a crucial part of any business growth strategy. I mean, imagine having the superpower to identify customers who are at risk of leaving, knowing why, and coming up with retention strategies to stop them from switching to alternatives. The engine's Customer Churn Prediction Template provides a complete machine learning solution for predicting churn before it happens. All right, moving on to the last question. What do you think causes a customer to churn? Yes, the answer is actually all of the above. Like I said before, customer churn happens to all businesses, even the best ones, and there's no way to ever stop it completely. But utilizing a machine learning template solution for customer churn prediction opens up plenty of opportunities for many businesses and industries. Not only is it easy to use, it also provides a complete machine learning solution from start to finish so that users can get their predictions in a matter of minutes. PI Exchange wants to take democratizing AI to the next level so that anyone, including a marketer like myself, can easily build machine learning model with this template. Although there is no single action that can be taken in preventing customer churn once they've been identified, it can often be as simple as reaching out with targeted communication or an offer or discount of some sort. This way, you'd have all the ingredients you need to proactively implement retention strategies so that you can keep your customers from jumping ship. All right, let's now get straight into describing the use case for today's walkthrough. As you will see, we will be using datasets from an example Telecom use case. Ramanan will share more details about the dataset later on. For those of you who are just joining us, welcome to the webinar. We are just about to start the walkthrough in a bit. Again, if you have any questions or if you have a specific use case you would like some help with, feel free to contact us or book a free demo with our team. All the links can be found in the chat box below. For now, Ramanan will begin his walkthrough. We will also reserve a couple of minutes at the end for a Q&A session, so if you have any questions, we will be happy to answer them for you at the end of the walkthrough. For now, I'll pass the time to you, Ramanan.
Let me quickly get started. So we said, as Fiona introduced earlier, we'll be looking at a churn prediction with machine learning use case in the telecom industry, right? What is the context here? So assume that we are a telco and we are trying to predict churn, right? And we will need to predict which customers will be terminating their mobile plans in the near future. Assume that all of them we are looking at month-to-month customers, right? We need a 3-week buffer before the customers churn to take action. So we need to predict 3 weeks in advance. And we need to focus on customers who churn in the near term, right? So customers who will churn in the 3-week period post the buffer, those who churn earlier are considered it's too late to reach out to them because it generally takes 3 weeks for any marketing effort to, any reach out program that you may have, right? So there might be some approval processes, to go through, etc. Yeah, so basically these are the two important time windows of churn for the business that we're looking at. So let's say that from today, so let's say I'm looking at the data today, right? And I predict that some customers are going to churn in the next 3 weeks, right? Then they're considered, too late to retime, right? So they will exit your business no matter what you do, right? And for these customers, right? They're predicted to churn in the near future, right? So because you have limited resources, you can't just reach out to every customer and try to keep them happy, but you try to keep the ones that are likely to churn after a certain amount of time. Try to keep them happy by offering some discounts, right? So the churn use case goes hand in hand with next best offer, which is also supported with the tool that we're going to use, which is our product. Yeah. So what data does our telco have? To look at that, I will quickly look at the data that I've already uploaded. The first data set that you have is a list of customers, right? With the registration date, like the date when they signed up for the mobile plan, right? And for the customers who churned, we have the churn date. For the rest of the customers, we don't have the churn date because they're active, like they're still using your product. Right? So we have some examples of churning customers, right? That's one data set. We also have a data set of bills that have been sent to different customers, right? So what was the billing amount, total amount, and what is the breakdown into different categories, like the fixed recurrent amount, the amount spent on the value-added services, any additional usage or roaming. You have the bill sent for each customer on different dates, right? So you have that information. You also have a log of all customer service requests that you have across all your call centers, basically. You have customer support team, and the calls are taken at a call center, right? And you have, for each call, you have the customer ID, the time when the call was initiated, when the call was received, basically. What was the type of the call? What was the outcome of the call? How much time in minutes the customer spent waiting in the queue, and what was the duration of the call, right? So we have this information, right? Let's quickly maybe summarize what we got, right? So we have a data from a period in history, right? And here in this case, it's March 2022 to March 2023. Sorry, there's a typo on the slide. It's not February, it's March. We have information about subscription dates, which is for the past and current customers, the date when they signed up for a plan, and for past customers, only the date when they terminated their plan, because current customers are still active. They haven't terminated the plan yet. We have billing data of customers active in the selected period. We also have call logs data from the customer service center covering every customer service call that was made during the selected period. So this is the context, right? The challenge to machine learning is to understand if any model can learn to distinguish churners from loyalists in historical data by analyzing behaviors in earlier time windows. So if there are behavioral patterns that indicate future churn, if that correlates with the churn behavior in the future, that is something that you want the model to pick up from, and also something that you as a marketer, in a telecommunication company, also want to learn about, right? So that you can take preventive churn actions. So that's one challenge. And of course, the challenge is to, it's also to save, the ultimate challenge is to cut costs, right? How much can you cut cost, for your marketing program, right? By exploiting machine learning, right, to predict customer churn. So to walk you through this, I'm not going to take you through any, hundreds of lines of code. I'm not going to run any code or anything like that. So what we're going to do is we're going to use our flagship product, which is, so our product is about democratizing data science, right? So we want to bring in the capabilities and skills, the capabilities and the tools, the capabilities and the tools that are required to build machine learning pipelines, for people who are not hands-on, software engineers, hands-on, data scientists, but people like maybe some in the audience, right? You might be a domain expert, you might have domain level intelligence, you might have domain level problem solving skills, right? but you don't necessarily have access to the tools and and the software packages, right? So what we do is we have a set of templates, right? And the first one is the Customer Churn Prediction Template, where you can just define your problems, like the parameters of your goal. So the goal is to predict churn. So you can define the parameters of churn, and then you can provide the data sets that are required for using the template. And then you can provide the periods that you are looking at in the future for churn, and then you can provide some additional domain intelligence, or business intelligence inputs that you have, that you may have, and then you just issue the build models. You don't have to you don't have to be familiar with any machine learning software packages or tools or such things. So with this kind of setup, all you need to do is provide the as I said, provide the source, the data connections, define the problem, provide domain knowledge inputs, and then set the desired schedule for running predictions, right? The AI and analytics engine will automatically take care of ingesting, preparing the data sets, and training the models, generating the predictions, and then running the pipelines on schedule. And in the end, you have the prediction store, you have the insights and APIs for custom dashboards, ready to consume. So you just define the problem, provide the data, and then just press a button, right? And after some time, you get the insights and predictions ready to consume. So that's how templates work on the engine. And this particular problem, it falls very well into the subscription churn, the subscription option within the customer churn template. So we'll be going with that. So the next part is the demo. As we have already introduced, we have our data sets here. So I have my subscription dates, right? I have my billing history. I have my customer service request history, right? And then I also have some additional information about customers, like for example, the date of birth, the gender. You may have more information, for example, education level, employment status, marital status, etc. Right? Or household size, annual income. Depends how much data that you have about the customer, right? So you can have as much information about in your customer record as you have. So the next step is to show you how we will go about building a machine learning solution and use it, and then understand how the predictions can be consumed, and also how it impacts your business in terms of what you actually gain in terms of ROI. So let's go ahead. I'm going to click on. So there are two ways in which you can build a machine learning solution with our platform. One is called build from scratch. One is called use template. Right? So both are suited for people who do not code. Right? The first one is more suited to data analysts and data scientists who want to quickly build a solution, but they want it to be highly customized. So it's still a no-code point-and-click tool but you can drag and drop components of a machine learning pipeline, for example, importing data, preparing data, and then choosing the type of machine learning solution the type of machine learning problem that you want to solve, the type of model that you want to build, etc. The features and everything. You can use the build from scratch to do that, or you can use the template. If you're a business user and you don't know how to build a machine learning solution, or you don't know the components of a typical machine learning pipeline, and you don't know how to orchestrate it either, right? So that kind of user persona is well suited to the templates. So let's jump into the templates because it suits to our business problem. So as you can see, the first template that we have is the customer churn prediction, and as Fiona introduced, it supports two different cases. One for subscription-based businesses, and one is for transaction-based businesses. The goals are quite different between the two, right? So let's go ahead and create this. So in the next few steps, it just asks you to provide the business-specific context, right? So you're not specifying any data preparation steps. You're not writing any code. You're not installing any machine learning packages or interacting with machine learning packages, but you're just providing data and providing your business goals, right? So there are two options, like, here I want to predict if my customers will terminate their paid subscription. That's what I want to do. The other option is, it says, predict if transaction activity of my customers will go down in volume or frequency, right? So that's for retail-based businesses, like, for example, if you're a supermarket or if you're an online e-commerce store, customers don't pay a monthly fee, right? Typically, they would only be making purchases whenever they want. So you want to know whether the loyalty of the customer has shifted, right? So in that case, you will measure the volume of transactions and the frequency of transactions in some time period, and then decide that, okay, so it looks like they have stopped using our product, right? So that's the kind of prediction that you want to make. But here in our case, like, it's different. We have a definite, so the customer, provides a definite signal that they are canceling their service and they will no longer use your service, right? So next, it tells you what kind of data sets you need. So we have the subscription starting churn days, as you saw. We have, so it asks for one or more event logs, right? So there can be different types of events. Like, for example, you can have history of calls, like, login sessions, complaints. You can have, MMS messages, web browsing history of the customer. You may have, anything like, amount of data usage, etc. Right? Or like if they use your app, like, what kind of activity they do in the. So, for example, if you have a, if your telco, if you as a telco, like, also, let customers install an app, for their account, right? So you can also track their activity in their app. So you can have a lot of different types of events, but in this case, for this presentation, right, like, we just have two, the bills, right, which I showed earlier, and then the customer service requests. So those are the data sets I'll be adding, and then I have additional customer information, right? So it very well suits this template. So I'll go ahead. So I just need to add some data sets, right? So either I can import data sets, or if I have previously imported data sets, I can reuse them. I'll just quickly show you the import options. You can use files, you can use data connections, you can use remote storage services. So a machine learning solution would typically need a lot of flexibility in terms of ingesting data from different sources and combining them, and and creating combined data views, right? So that you can go ahead and solve your problem, right? So okay, so let's so having seen the import options, right, like, we don't have to go through them because I already uploaded to the platform. So I will just use an existing one. So I have this, which I imported earlier, which is the one that you saw here in this tab, right? So I'll just go ahead and say, okay, this is the data set I want to use. So in the next step, it says, it asks me to select the columns that contain vital information about in my data set. For example, it's asked me which column contains the unique customer identifier. So I have the customer ID column for that. Which column contains the date and time when the customer started their subscription plan. So I have the registration date. When the customer churned, this can be the churn. This will be the churn date, right? That's it, right? In the next step, I can add the events logs. Like, the first one I will be adding is the bills sent in the past to different customers. So I have that. And then the other one that I'll be adding would be the customer service calls history, right? Call logs, basically, right? So the next thing it's asking me is to provide a label for each type of event, so that it, when the platform, generates a data set, it can distinguish different event types. So here I would say this is bills. So I have like, it can be something like voice calls, text messages, etc. But here I have bills, and here I have customer service calls, and then the unique identifier column, and then the timestamp of the event, and here again the unique identifier of the customer and the event timestamp, right? So this information is provided so that the engine can process the data sets behind the scenes and join different data sets, by the customer ID key. So save and continue. That's it here. So then I add another data set which contains demographic information about customers, right? Which is just simply here. It's the date of birth and gender. You can add it like you can add as many features as you like. There can be more attributes of customers. Okay, so let's save and continue. All right. So in the next step, I'm going to define the periods that I showed you earlier. So what is too late, considered too late? If they churn in the next 3 weeks, that's 21 days. What is considered about time? If they churn the 3 weeks following the 3 weeks, which is the neither too near term nor too long term, so that's the short term, manageable short term customers whom I want to focus on, so that I can reach out to these people, right? But first, I want a model to be able to predict which customers will be in that category. In the next step, here is an important thing that you need to do when you are using machine learning solution. You need to bring in your domain knowledge expertise, right? So it's automatically filled up some things, but you'll have to check it, right? So what is it doing here? You can see some information in the view guide, so what happens is, from the events datasets, it's going to pick up a particular column and then select a date range, for example, 30 days. So what I'm going to compute is what the customer has done in terms of call duration in the last 30 days, the most recent 30 days, right? This is just an example, recent 30 days. It can be any rolling date range that you can define, and I'll quickly show you how, right? And it will compute the stats, so for example, what was the average call duration of the customer in the last 30 days? What was the maximum call duration, the duration of the longest call made by the customer in the last, in the last fortnight, for example, right? So these could be, so these are the hypotheses that you have, saying, okay, I believe that if you look at these particular, behavioral statistics, there'll be some pattern, which can foretell that the customer is going to churn, right? So this is up to you, this is your domain expertise, right? So then basically what I need to do is I can choose those columns which on which those aggregate stats will be computed. Then I choose the time windows, right? Then after that, yeah, I mean, I can customize the time windows, right? So basically, let's maybe quickly look at one. So I can say, the 7-day range, 7 days ago, 14 days ago, or 14-day range 14 days ago, which will be the fortnight before the previous fortnight, right? So if that's the date range that you're interested, then you should, you should do that. So yeah, so far that's good, and we can also inspect what are the things that it's going to be using, so it's going to be looking at the statistics of the recurrent amount. It's going to be looking at the statistics of the different breakdowns, and then from the customer service calls, it's going to compute things like the average wait time, things like this. Then you can quickly say, I'll deselect the gender, right? And we can go ahead, right? Next, what we will do is so we'll have to decide how many models that we want to train, right? So let's say I want to train use three algorithms, and say that I want the training to be, I want to go ahead with the training if if it's likely that the algorithm will take less than 30 minutes, so basically select the algorithms based on estimated training time on these data sets. So these are important auto ML tools, that any business analysts would need, and any business user would need, so that they don't have to, we also have the option to manually choose algorithms. If you're familiar with machine learning, you would know, what is light GBM, what is logistic regression, what is Gaussian naive Bayes, what is different kind of boostings. But if you're not familiar, just do this, right? And we will find the best algorithms and train them for you. And after that, you just click on start building, and after some time, you're going to have results, right? So there you see that the engine is going to be importing your data sets. It's going to generate training data from your imported data sets and combining them into one, and then analyze that, and then pre-process the features, and then it's going to kick off the model training, right? I'm not going to sit here and wait because it will bore you guys definitely, and I want to get back to another important part of the presentation, right? So I'll just go show you one that I made previously, which is ready. So here, what do we have? We have we see that there is some summary information about the app. So app is a space where you can experiment with multiple models at the same time. You can compare the models. So you see that it uses 4 data sets. And then there's a data preparation process. You see that there are things that so basically there are these 4, 1, 2, 3, and 4 data sets which are being sent into a data preparation process, and then they combine together, right, and then into one training data set. Now you can even look into the different steps, right? So you can see all the steps that have been taken on this data set. So it has computed some lag features. It has computed some some features about from the time windows that you defined, right, from the date ranges that you defined, and from the columns that it chose. For example, here it is computing the minimum recurrent amount in the bills in the 30-day period ending 30 days ago, right? So you have that, yeah, and you have lots of them, and you have also look at the recent. It's also looking at the recency features. For example, the days since the last bill was paid. And then yeah, so you can see different steps that have been taken in the pre-processing of the data. And then in the end, you have a training data set, which consists of for each customer. I'll quickly wait for it to load. Yeah. So basically, you have for each customer at each point in time in history, what was their usage at that point, right? And then by looking at by looking from that point into the future of that point, right? Then you look at whether the customer has churned or not, and whether the customer did not churn in the next 21 plus 21 42 days, whether they churned in the 21-day period after 21 days, etc., right? So that becomes your the data on which your models are trained. So basically, your model makes use of these variables, right? The ones that we created, ones that the template created for you, right? So you didn't have to sit down, decide the different data preparation steps. We just provided the business inputs. You just provided the data sets, and the automation is done for you automatically. So this lets us focus on the problem at hand, right? This is the kind of tool any business would need to make full use of its domain experts and domain level problem solvers, right? So you don't have to worry about the mundane tasks. So once everything is ready, you can see the top performing model, and you can also see its performance. So we also have something called feature importances. If you're familiar with machine learning, you would know. But basically, it shows how much each feature in your data impacts predictions. So the most influential contributing factor is the maximum additional usage amount in the bills in the last 30 days, right? So it's automatically created these variables and also named them, in a way that you would understand, right? And then you have the variables in decreasing order of impact on the model predictions. you can look at similarly the variables that affect the 3 different classes. So basically we had 3 categories, right? Like about time, safe, and too late. So yeah, so you can see the contributions. You can also see a sample of the predictions generated by the model with explanations. So for example, here it says for this particular customer, right? It's about time to reach, right? Like, so it shows the probabilities of the 3 different classes. So the about time is the one that's dominant. And then you can see exactly why this prediction was made by the model. So you see that you see the contribution from each feature, like for that prediction, basically, right? And you can also see that in chart form. Yeah. So you can see what are the top most impacting features. Yeah. So once you're happy with the model, you can also, by the way, look at detailed model performance, like for example, the confusion matrix. I will quickly touch into this, a little later. You can also look into different scores. If you're familiar with machine learning, like for example, precision and recall. Accuracy is high, but it's not a good metric to measure prediction quality. We use something called macro average F1 score, like the 78.5 quality that you saw comes from there, comes from that one. Basically, it's a balance between it's basically a balance between so if you're predicting a very rare occurrence, right, like a very rare category, right, accuracy is not a good measure, because you might as well be saying that everything is like the other category, which is quite most common, right? So then you will be correct 99% of the time, but the 1% of the time that it really matters, you'll be incorrect. So therefore accuracy is not a very good metric for that. All right, so we have seen all this, right? And then once you're happy with everything, you can make a prediction, right? You can either make a one-off prediction with new data or like existing data, or you can make scheduled predictions, right? So when you schedule predictions, like what you do is you first choose your model. Once it automatically selects the recommended model for you, then you provide the same data sets with the same schema as you originally provided, right? You can provide mostly database connections here, because it's going to periodically fetch new data from these connections that you nominate here at the stage step. So basically, this is like putting into production, right? Putting your machine learning pipeline into production and using it on a regular basis. And then you can define the output destinations, and then you can define a schedule. Say, I want to predict every, the last day of every month, so that I have on the morning of the first of the next month, I have the fresh, updates about my current active customers, and I also have like the previous predictions validated. So let's maybe look into the one-off prediction, because it's easier to demonstrate here. So the recommended model with the highest prediction quality. So then I can use the data that I already uploaded to predict for my next period, right? So because my data spans from March 2022 to March 2023, I can predict the likelihoods of churn for a future timeline, right? So I can do that. Go ahead and run prediction. So it's quite easy, right? And once predictions are ready, they'll be available. They'll be available here. You can preview the predictions. It provides you with all the customer ID, the time at which the prediction was made, and all the attributes that were taken into consideration for making the prediction, right? So that's all available here. Like the ones that it generated. The tenure of the customer was generated, like you see there's a column called tenure. It was generated from the the registration date, right? And then it has all the, so basically it has all the currently active customers in your data, and then the probabilities of the 3 different classes. For example, this customer is a little bit of a, it's probably too late, but it's also probably worth looking into it, because there's a 40% chance that they will be churning only 3 weeks later. For this customer, they're quite safe, right? Like 89% chance. So you can set a risk level that you're comfortable with. For example, here there's a 33%. So whether it's worth looking or not, it's up to you. Here it's quite clear, because it's 50% for this category. It's 17% and 32% for the other 2 categories. So the predictions provide you the full information and not just the yes or no, like the binary answer, like whether it's A or B or C, right? Like it doesn't provide a simple A or B or C answer only, like but it also provides more information by saying, okay, it's A, but with this likelihood, it's B with this likelihood, etc. Once you have done this, you can download the predictions, right, as a CSV file or any file format that you're comfortable with. We support JSON lines and Parquet also. You can also export the prediction as a data set, or you can also export it as a table in your database, right? You can set up a database connection and then say that I want to export my predictions into a new table. It can do that. And once you have this data exported, you can then open it in, let's say, Google Sheets, right? And you can provide some analytics, right? Of your predictions, right? So here we have like 3 different. So we have like a bunch of customers in the about time category here. For the safe customers, like most of the customers are safe, like as we can see. It's only the small base of customers, like who are about to leave your business, like that you need to convince. And then for the too late ones, like it's I mean there are not too many of them, like right? So we are in good shape. So you can consume the predictions and make dashboards in Tableau. You can make dashboards in Power BI or Tableau, any tool that you're familiar with, right? Comfortable with, and then provide the business specific dashboards that you need for reporting. We need to look at the economic benefits of making of the ML predictions, right? Let's look at an example scenario. So for this example scenario, what we have is that, like we know from analysis of historical data that every month there are 100 customers who are in the about time category, like they'll be churning in the 21-day period after 21 days, right? And what the marketing team decides is they want to mitigate the churn by reaching out to a target segment every month with a $20 discount offer on their mobile plans, right? Typically they are $65 plans, but with a $20 discount, it'll be $45 per month, right? The ones that are too late, they will not take the offer. Okay. The safe and the about time customers will take it, right? So this is like a one-time $20 discount for the month, right? If a customer is lost, we need to acquire a new customer, right? And there'll be some cost to it, like So what we want to understand is what is our marketing cost with and without the model on a monthly basis. With a model, we can find a target customer base, like the about time customers, right? Without a model, we don't have a target. So basically, we lose the customer, and then we react afterwards, like by trying to acquire a new customer, right? So if you lost 10 customers, then you should step up a campaign where you can acquire 10 customers easily. So to have further information on the cost analysis, the monthly cost of offering the discount to about time and safe clients is $20. As we saw, it's a $20 discount. Monthly cost of losing a customer is $60, like which is the revenue minus operational cost to serve the customer. The average time required to acquire a new customer is 1.5 months, like or 1 month, let's say, right? The average cost of acquiring a new customer is $45. So that's a one-time cost that your marketing team has to pay whenever they acquire a new customer. So this is basically from, like say if I spend $45,000 in a marketing campaign, right? And if I get 1,000 customers out of that, right, then my acquisition cost is $45. So with and without the model, as I said, like with our model, what we would do is we would pick the customers who are predicted as about time and then offer them a discount. Then we will then without a model, what we have to do is acquire a new customer every time a customer churns, right? So we saw the performance of the model as a confusion matrix. Like I will explain it a little bit more. So basically, what this means is, so on the x-axis you have the predicted, on the y-axis you have the actual, and you have the numbers inside, like so which shows. So here there's a 74. So basically, it says that the model when the model for the 74 of the predictions that the model made as about time, like they're actually about time, right? Maybe I'll explain it a little more. If you look at one particular column, right, the total number of predictions made by the model. So first of all, the total customers is like, the sum of all these numbers here, like 1,531. Out of those, the model predicts, like, you have like 74 here, you have 54, you have 12, like, so so that's a total of 140 customers are predicted as about time, like, out of which 74 are correct. So basically, it's correct about, like, 50-60% of the time, I would say, or 50. And out of the ones who need to be reached out, like, who are the actual about times, that will be 74 plus 3 plus 28, 105, like, so out of the 105 who need to be reached out, the model identifies 74 of them, so which is like 70%, right? This is interesting, right? Like, it might not look impressive at this point, like, we're only capturing 70%, and out of the 140, like, we are right only 50% of the time. But what you should be really looking at is the cost, right? So if I don't have a model, as we said, if you're only replacing churn customers, then all of these customers will, you don't reach out to them, all of these will be churning, like, 74 plus 3 plus 20, that's 105, right? So all of these 105 customers need to be acquired, and there'll be $135 net acquisition cost because of the lost revenue from the previous customer, and the like, $90 lost revenue with, like, assuming a month and a half, like, until you get a new customer, right? Plus $45 acquisition cost would be 45, so 90 plus 35 would be 135. So you'll be spending 14,000 every month on your campaigns, right? But if you use the engine's churn prediction model, right, you offer a discount to all of these people. Like, the too late ones won't take it, right? But the ones who are safe, like, they're happy with the discount, so they will take it. The ones who are about time, they will take the discount and reverse their decision to leave the business, right? Some assumptions are being made, but, like, it's to illustrate the point. Like, it might be not exactly be, like, 100%, in the most accurate, business scenario, but it's a kind of a simplifying assumptions to aid the discussion, right? So you have $20 retention offer cost, right? So basically, when you offer a $20 discount, like, so you have to, so the $20 is lost from 74 plus 54 customers, right? And for the remaining customers who you didn't reach out, like, 3 plus 28 who are about time, right, in the actual category, right? So you need to acquire new customers in that place, right? So again, 135 per customer to net acquisition cost. So the total marketing campaign cost is only 6,745, which is like you've basically more than halved your marketing cost with the model. So that's the kind of message that you want to take, and that's a kind of machine learning that you want to apply in your business, to make good business decisions. Yeah. So pretty much that concludes my demonstration and my walkthrough of the use case. I will now hand it over back to Fiona. Thank you.
Again, thank you, Ramanan, for taking us through the demo and also for showing us how to use the customer churn template. Just a quick summary. Customer churn is really important, and accurately predicting who is likely and understanding why it's happening is definitely the first step in creating a retention strategy. Our customer churn template allows you to do this in a few simple steps and in the most efficient way possible. It is definitely perfect for marketers, growth, and customer success specialists. But also stay tuned because we will be introducing more templates in the future, such as customer segmentation, next best offer, and demand forecasting. Once again, thank you so much, everyone, for joining us today. We really hope you've gotten something valuable out of this event and that you are ready to start your journey with machine learning. Let's continue this conversation on our Slack community channel. We're happy to answer any questions you have there. If you have a use case in mind, simply book a free demo with our friendly team. Also, if you're ready to try out the engine, we have a 2 weeks free trial for you. Like I said before, you can find all these links in the chat box below. Thank you, everyone. I hope you have an amazing rest of the week.